problem in root-locus diagrams. The problem statement goes like this. Show that breakaway point, break-in point, if any, on the real axis for the system in the form GH of s is equal to k into n of s by d of s, where n of s and d of s are polynomials in S, can be obtained by solving the equation dk by ds is equal to 0. So, in any root-locus problems, if at all if there exist breakaway break-in points, those breakaway break-in points can be obtained by solving the equation dk by ds is equal to 0. We know the rule how to find breakaway points, break-in points. There I said dk by ds is equal to 0. This is the equation, and solve this equation. Whatever the roots you get, those roots are either valid or invalid breakpoints. So, in this derivation, let us see whether this particular dk by ds equal to 0 roots really valid or invalid breakpoints or invalid breakpoints, whether it is correct the method is. Now, so the open loop transfer function given it as gh of s is equal to, we have k into n of s by d of s. So, n of s, d of s both are polynomials. So, n of s is a numerator, d of s is a denominator. Then when you solve the n of s, you will get open loop zeros. When you solve d of s, you will get open loop zeros. Now, so in this case, first thing is we write the characteristic equation. So, what is the characteristic equation? 1 plus gh of s is equal to 0. So, now we can say that 1 plus we have k into n of s by d of s is equal to 0. Then I can write it as a d of s plus k into n of s is equal to 0. This is a characteristic equation. Let this equation number it as 1, equation 1. So, what is equation 1? D of s plus k into n of s is equal to 0. Now, I am going to differentiate this equation 1 with respect to s. Then if you do that, you will get d of s. We have let us say that characteristic equation is q of s. What I want to do is dq of s by ds, I need to get it. So, if you get that, you will be at d of s by ds. So, small d is a differential operator, capital D is a polynomial we have. So, d of s by ds plus we have already k and k d n of s by ds, and if you equate it to 0, that will be equal to 0. So, differentiating with respect to ds, this equation 1 and equating to 0. Then if you rearrange this, I want to take the k left side, that means k is equal to, then we can write it as in the brackets d of s by ds over d n of s by ds. So, this is the k. So, at this k value, your characteristic equation will have multiple roots, because what is a breakpoint as per the definition? At breakpoint, your root locus branches will come and meet there. What does that mean? Your both closed loop poles will stay there at particular k value. So, at breakpoint we will have k, at that particular k value the characteristic equation will have multiple roots. So, that k value is this. Then what I am going to do is substitute this k in the characteristic equation. So, if you substitute this in the characteristic equation, and we know that q of s is equal to, we have d of s plus k into n of s is equal to 0. Then that k I am going to substitute here. So, d of s, k is minus this, so minus we have d of s by ds divided by d n of s by ds, and close the bracket, we also have n of s is equal to 0. Then we are substituting that k value at that k value where the multiple poles you will be having for the characteristic equation. Then that equation now it is going to be like this. Then if we rearrange them, we can say very easily we will have d of s into d n of s by ds minus n of s into d of s by ds is equal to 0. So, this is the equation. When you solve this equation, then you will get the breakpoints, because we already taken care of that k, that particular k value where we have the multiple poles in the characteristic equation. So, this equation we name it as equation number 2. Then again we will take the characteristic equation. What is that? D of s plus k into n of s is equal to 0. What I need to show, the dk by ds is equal to 0 equation is that the equation of the breakpoints or not. So directly I will take now here dk by ds is equal to 0. So before that, let us find out what is k. From the characteristic equation, k is minus d of s by n of s. Then dk by ds is equal to 0 we want. So we know how to find differentiation. We can use u by v rule. So you are going to get dk by ds is equal to 0 minus, if you open the bracket, n of s d of s by ds minus d of s into d n of s by ds over we have n of s whole square, and this must be equal to 0 because dk by ds is equal to 0. Then if you do this, then you will be getting it as again d of s and dn of s by ds minus n of s d of s by ds is equal to 0. This is equation number 3. Now if you look at equation 2 and equation 3, both are same, which means the equation 2 is the equation to find the breakpoints or the multiple roots of the characteristic equation for particular k value, and this is also same thing. Therefore, instead of solving equation 2, then we can take the equation 3 which has come from dk by ds equal to 0. Hence we can prove that when you solve dk by ds equal to 0, then you will get breakpoints or breakaway points or break-in points of the system if there exist in the given open loop transfer function.